adult solutions. Add-on desired.
Welcome to Adult Solutions. Myself Santoshi Reddy and I am your chemistry faculty. So today we are going to study about the 11th standard chapter stoichiometry. Okay, so we'll be dealing with this chapter. So it comes under the physical chemistry, and to understand about the physical chemistry, this chapter is very much important for your Neet. So now let us start with the introduction of this chapter. So this stoichiometry, it has been derived from the Greek words. The word stoichiometry, it has been splitted into two words, that is the stoichion and metron. So stoichion is nothing but it means element, and metron is nothing but it is the measurement we are having. So togetherly we can say that the elements measurement we are going to see here. Okay, so as I just told you that this is a very important one for the physical chemistry, to understand the physical chemistry. So let us see about this. So the matter has been divided mainly into two, that is the mixtures and pure substances. Further, these mixtures has been divided into two as homogeneous mixtures and heterogeneous mixtures we are having. And the pure substances, further these are divided into elements and compounds we are having. Now one by one we'll see about their definitions. What is matter, what is mixtures, pure substances, we'll see one by one. First of all, let us see about the matter. So matter is nothing but anything which occupies space and has matter and has mass, we call it as a matter. Okay, so as we have seen that matter, anything, whatever you are going to take, so this pen is also matter because it has a mass and it is occupying a space. Okay, so this board is also a matter we are having, book, pen, even ourselves is also a matter. Anything in the universe which is occupying space and has mass, that we call it as a matter, we can say. Okay, so here the matter has been divided into two as we have seen, that is the mixtures and pure substances. So first of all, let us see about the mixtures. So mixtures are nothing but which have a variable composition, we can say. Okay, and these mixture, they can retain their characteristics, properties by the physical separation, we can say. Okay, and these can be separated into their pure substances by applying a physical method, we can say. Okay, so mixtures of different components, they have the different may have widely different properties we are having. So mixtures are anything and but whatever we are mixing. Okay, so generally you people might have heard the food dish we are having mixture. Mixture is nothing but they are all adding all the peanuts, puffed rice, okay, and all the other stuff they are adding. So that is nothing but we call it as a mixture. So anything which is added simply like that, okay, so that we are calling it as a mixtures, we can say. So further, these mixtures have been divided into two types, that is the homogeneous mixtures and the heterogeneous mixtures we are having. The name itself is indicating homo means same, hetero means different we are having. Okay, so homogeneous mixtures means we are having if they are having a fixed composition. Okay, so if they are having a fixed or same components when they are present, then those we are calling them as the homogeneous mixtures. And heterogeneous mixture means different types when they are mixed with each other, we are calling them as the heterogeneous mixtures, we can say. Okay, so now let us see the next one we are having, the pure substances we are having. Okay, so pure substances means these are having the fixed composition we are having, and they cannot be separated by the simple physical method. Okay, so they cannot be separated by the simple physical methods, and the properties do not vary. Okay, so the substances properties, they are not varying, we can say. So such a one we are calling them as the pure substances. The example here you can see that we have taken a pic of a diamond. Okay, so diamond is nothing but it is made up of purely carbon we are having. Okay, and this is a graphite we are having. So graphite is nothing but it is also purely a carbon we are having. Okay, so in which we are having only one type of element present, and these are the pure substances we are having. So these are the best examples we can give for the pure substances, that is the diamond and graphite we are having. Okay, so these diamond and graphite, so purely these two are having only the carbon in them. And if we are taking the glucose as an example, okay, so glucose, as we know that, so we are having a formula of C6H12 and O6. Okay, so this is the formula we are having for the glucose. So it means that glucose consists of carbon, hydrogen and oxygen in a fixed composition we are having. Okay, so the fixed composition here we can see that we are having 6 carbon atoms, 12 hydrogen atoms and 6 oxygen atoms we are having. So these are present in the fixed composition, and these are known as the pure substances, we can say. Okay, now so these pure substances, these are further classified into two types. Those are the elements and compounds we are having. Okay, so we'll see one by one. Let us see about the elements we are having. So an element is nothing but which consists of only one type of atoms in them. So those we are calling them as the element, we can say. Okay, so these elements, they cannot be decomposed by the chemical by the physical method, we can say, okay, into the simpler substances. Okay, so this we call it as an element. So as we can see that in the periodic table we are having about 118 elements we are having. So these elements are the pure substances we can have. Okay, so the examples you can take any of the example: hydrogen, helium, lithium, boron, carbon, oxygen, sodium, gold, platinum. Okay, so whatever the element you are picking up from the periodic table, so all those are nothing but those are the elements we are having, in which we are having the same type of atoms we are having. Okay. The next one we are having about the compounds we are having. Okay, so compound is nothing but when two or more elements combine in a fixed composition by their mass. Okay, so those we are calling them as the compounds. Okay, so those we are calling them as the compounds, and the constituent elements present in them, they do not retain their characteristic property, we can say. Okay, so let us see a few of the examples of the compounds we are having. So here you can take the example of water. So this is we are having the water formula we are having H2O. So here we are having two different elements, that is hydrogen and oxygen. These are the two different elements we are having. So these two different elements, when they are combining in a fixed composition, okay, so two different elements when they combine in a fixed composition by their mass or weight, so we are calling them as the compound. So here you can see that it consists of two hydrogen atoms and one oxygen atom. Okay, so this is a water compound, we can say, and this water is even known as a molecules. Okay, so if the atoms, if we are having only 2 to 3 atoms in them, then even we can call them as the molecules. Okay, so if the same atoms are combining, only 2 to 3 atoms are combining, same atoms are combining, then we are calling them as the homogeneous nuclear molecules, okay, and if different atoms are combining 2 to 3 atoms in a different with a different elements, okay, then we are calling them as a heteronuclear molecules, we can say. Okay, so generally we are calling them as the compounds. If we are having more than that, then we call them as the compound here. The next example we can take is the carbon dioxide. Okay, so CO2 is nothing but this is the carbon dioxide we are having. Okay, so in this carbon dioxide you can see the ratio here. We have taken one element of carbon and 2 elements of oxygen, or we can say 1 atom of carbon and 2 atoms of oxygen. So this is giving rise to a carbon dioxide. Okay, so similarly another example here we can see, this is a ammonia we are having. Okay, so in ammonia, what are the 2 different elements here? The nitrogen and hydrogen. So it consists of 1 nitrogen and 3 hydrogen atoms are present to form a ammonia. Okay, so this we call it as a compound. Now, see in the mixtures, as we have discussed earlier also, so mixtures are further classified into 2 types, that is the homogeneous mixtures and heterogeneous mixtures we are having. So homogeneous mixtures means which have the same composition throughout. Okay, which have the same composition throughout. The best example we can give is the salt water or the sugar water. Now if you are taken a glass of water and to that if you are adding a tablespoon of sugar or salt, and in another glass you take a same water, plain water. So by observing that, can you tell that which is a plain water and which is a salt water or a sugar water? No, we cannot identify through our eyes that which is a plain water or which is the salt or sugar water. So such a type of mixture we are calling it as a homogeneous mixture, we can say. Okay, so these components when we are mixing with each other, we cannot distinguish that it contains the other substances in them. Okay, and the example here we can see the sugar solution and gaseous mixture. So as we know that in this atmosphere we are having so many gases together. That is atmospheric gases, we are having oxygen, we are having nitrogen, carbon dioxide, but are we able to identify these gases? No, we are not able to identify. So this is also a homogeneous mixture, we can say. Okay, so this is what we have given here, a pic of a salt water. So here you can see, so you cannot, it is difficult to identify that which is the salt water and which is the plain water here. Okay, now coming to the next is about the heterogeneous mixture we are having. So heterogeneous mixture means they do not have the uniformity. Okay, so the distribution or the composition is not same throughout. Then such a mixture we are calling it as a heterogeneous mixtures, we can say, and we can distinguish these mixtures by looking at them. Okay, for example, you can see here a picture where all the type of grains have been mixed with each other. By looking at that, we can say, we can observe that it is having a different types of grains and cereals has been mixed here. So this type of mixture we are calling it as a heterogeneous mixture, we can say. And here is another example of a heterogeneous mixture where the kerosene is mixed with the water. Okay, so here you can observe that the 2 layers have been formed between them. Okay, so there is no uniformity as we have seen in the salt water. In the salt water we cannot identify them. Okay, so this we call it as a heterogeneous mixture. So this is an example of a heterogeneous mixture we are having. Okay. Okay, coming to the next is about the properties of matter and their measurements we are having. Okay, so every substance has its own unique characteristic property we are having. Okay, and the measurable properties of matter, they can be expressed in terms of units, we can say. Okay, so they are expressed in terms of unit. So this has been the properties of matter. It has been classified into two types here. That is the physical properties, and we are having the chemical properties we are having. So the properties which can be observed, okay, the properties which can be absorbed without changing their composition, that is the chemical composition, we call them as the physical properties. Physical change which we can observe through our eyes, okay, so that we are calling it as a physical property. For example, color. Now if you are taking some conducting any of the experiment, then how can you say that it has got converted into the product? By changing its color. Okay, if it is changing its color, we can say that it has converted into its respective product, we can say. Okay, so this type of change what it is undergoing, so there is no chemical change taking place, but if the color is the physical property we are having. The smell also we can, through the smell we can say that so and so compound is present. Okay, so that is also a physical property, we can say. So the change which is undergoing, the physical change, not the chemical composition is not changing, okay, then such a one we are calling them as the physical properties. That is the color, odor, melting point, boiling point, density. So all these are the physical properties we are having. Coming to the next is about the chemical properties. So chemical properties means the properties which can be measured by a chemical change. Okay, so those we are calling them as the chemical properties, we can say. So the chemical properties are nothing but, we can say, the acidity, basicity we are having, okay, then the combustibility. So these are nothing but the chemical properties we are having. So acidity is nothing but the number of replaceable hydroxyl groups, we call them as the acidity, okay, replaceable hydrogen atoms, and basicity is a replaceable of hydrogen atoms we are having. Okay, so that is the acidity and basicity. It is nothing but to find out whether it is acidic in nature or basic in nature, and combustibility is nothing but whether it is combustible or not. Okay, so these properties we are calling as the chemical properties we are having. Okay, so here let us see one question here. Okay, multiple choice question. So matter is nothing but, okay, so the four options has been given has mass, second one we are having occupies some space, and next we are having both A and B, that is has mass and occupies space, or else the D option we are having no correct definition. Okay, so which one do you think that is a correct option for this question? Okay, so this is a completely a basic question we are having. So without matter there is nothing in this universe. Okay, so as we have seen the definition that matter is nothing but which occupies space and has mass. We are calling it as a matter. So here the both A and B is the correct option. So where you can see has mass, occupies some space. Okay, so this is the correct option we are having.
Add-on solutions. Add-on desires.